Have you ever looked at a tiny little circuit board and wondered how it could possibly power a smart home or be the brains behind some cool new invention? Well, today we're pulling back the curtain on the NodeMCU and the frankly magical world of wireless networking that makes it all happen. Let's get right into it.
So, here's the game plan. We're going to start with the big picture, the basics of wireless networks. Then, we'll zoom right in on the NodeMCU and its Wi-Fi capabilities. After that, we'll tackle how it gets its own unique address on a network, how it can talk directly to other devices, and then, the best part, we'll walk through getting your very own board set up and ready to go.
Okay, before we get our hands dirty with the NodeMCU itself, we need to understand the world it lives in. And that's this invisible web of wireless networks that, let's be honest, connects pretty much everything around us these days.
You know, we're swimming in these networks all the time. Your phone's 5G or LTE connection, that's a wide area network, a WAN. The Wi-Fi you're probably using right now is a local area network, or LAN. And those wireless earbuds you love, that's a super small personal area network, a PAN. For our purposes, the NodeMCU absolutely thrives in its natural habitat, the LAN.
All right, now that we've got the lay of the land, let's meet the star of the show, the NodeMCU. This little board is a huge favorite for makers and creators, and for one big reason, its superpower is built-in Wi-Fi.
You've probably seen 802.11 BGN on the side of a router box and just kind of glossed over it, right? Well, it's not some secret code. It's basically the different languages or dialects of Wi-Fi. Think of B as the original kind of slow version. G came along and made things a lot faster, and N was a huge upgrade, making things super efficient. The NodeMCU can speak all three, which makes it an incredibly versatile little communicator on almost any modern Wi-Fi network.
So, your NodeMCU speaks the language of Wi-Fi, but how does it actually join the conversation? Well, to do anything on a network, it needs a unique address, an IP address. And it turns out there are two main ways it can get one. This is the first, most fundamental question for any device that wants to get online, whether it's your laptop or a smart light bulb. If it doesn't have a unique address, it's basically invisible. So how does it get one? Does it just ask for one, or do you have to assign it one yourself?
And those two options are what we call dynamic and static. With a dynamic address, the network's router just automatically hands out a temporary address to your NodeMCU. Easy peasy. With a static address, you step in and manually assign a permanent, unchanging address to your device. You're in control.
I absolutely love this analogy because it just makes everything click. A static IP really is like your home address. It's fixed, it doesn't change, everyone knows where to find you. A dynamic IP, on the other hand, is like getting a new hotel room key every time you visit. Both give you a place on the network, but one is permanent and the other is temporary.
Now, this is where it gets really interesting, because this is where you, the creator, have to make a choice. If you're building something like a central home automation server that other devices always need to find, a static IP is probably your best bet. It's reliable. But if you're just making a simple sensor that wakes up, sends a piece of data, and goes back to sleep, the simplicity and added security of a dynamic IP is often the way to go.
So this whole automatic hands-off system is run by a protocol called DHCP. You can think of it as the super efficient concierge for your network. As new devices show up, DHCP is there to greet them and hand out a unique temporary room key, or IP address, making sure nobody gets the same one and everything just works.
Okay, but what happens when you don't have a Wi-Fi router? Maybe you're out in a field, or you just want two of your devices to talk to each other directly. Well, that's when you need to cut out the middleman.
And that is the absolute magic of Wi-Fi Direct. It lets two Wi-Fi-enabled devices create their own private, secure little network on the fly. No router necessary. This is perfect for when you need to quickly send some data or commands from one device to another right next to it.
And here's why Wi-Fi Direct is so cool. It's not just a dumb pipe between two devices. It's a smart and secure connection. It uses modern WPA2 encryption, which is super important for keeping your data safe. And the devices can actually negotiate with each other to figure out the best way to connect. It is a massive improvement over older, clunkier ad hoc networking.
All right, enough theory. It's time to get practical. Let's roll up our sleeves and walk through the exact steps you need to take to get the software configured and your NodeMCU ready for its very first project.
Seriously, getting started is as easy as 1, 2, 3. First, we need to tell our programming software where to find the right files for our board. Second, we'll install that software package and tell it which board we're using. And third,
we get it all ready for that first bit of code. Let's break it down.
Okay, first things first. We're going to be using the Arduino IDE, which is the software we use to program the board. The very first thing you do is go into the preferences and paste in a special web address. This just tells the software, hey, go look over here to find all the files you need for the ESP8266 chip.
Once the IDE knows where to look, you just pop open its built-in Boards Manager, type ESP8266 into the search bar, and hit Install. It'll go out to the internet and download all the essential tools, libraries, and examples you'll need. Super simple.
And the final piece of the setup puzzle is to tell the software exactly which board you've plugged into your computer. You'll go to the Tools menu, find your NodeMCU model in the list, and then select the correct COM port. That's just the USB port it's connected to. Now your computer knows exactly how to talk to your board.
And that's literally it. Just like that, you are all set. Your computer and your NodeMCU are now ready to work together. You are officially prepared to start programming and bring your connected ideas to life.
So, let's do a quick recap. What are the big things to remember? We learned that wireless networks come in all shapes and sizes, from personal to worldwide. We found out our NodeMCU is a multilingual Wi-Fi powerhouse, speaking B, G, and N. We know the difference between letting the network handle IP addresses automatically with DHCP versus taking control with a static IP. And we saw how Wi-Fi Direct lets us build router-free connections.
So we'll leave you with this thought. You now have the fundamental knowledge to connect a tiny, powerful computer to the internet and to other devices. The tools to build smart, connected things have never been this cheap or this accessible. The only question left is, what are you going to build?